Hello friends, let us start now. Right circular cone. What is right circular cone? Everybody knows the ice cream cone. That is what your right circular cone is. Very simple. You have a circle as a base. The circle has a radius. This is the height and this is called as slant edge. Okay, do you remember we opened the right circular cylinder and we got what? Rectangle. If you open this, you will get the sector of a circle. You will get the shape something like this. You will get shape something like this. You know that the joker's cap is there, triangular cap is there. That is also right circular cone. If you cut and open that cap, what you will get? You will get a sector of a circle. So just remember that. Now let us see the different formulas related to right circular cone. In this case, here also you have curved surface area, then you have total surface area, and you have volume also. Very easy. What is the curved surface area? When you open, if you get sector, that means the area of sector is your curved surface area. So what is the formula for that? When you open that, this L will become your radius. So the curved surface area of a right circular cone is radius upon 2 into length of arc. So length of the arc is what? Length of the arc is nothing but the circumference of this base circle, because when you open that, you will get the arc length. And what is this radius? Now when you open this slant height will become the radius, because when you open this, you will get the shape something like this. So this L is now becoming the radius of this sector. So here we have L upon 2 into length of arc. This length of arc is nothing but the circumference of this base circle, that is 2 pi r. So I have this 2 will get cancelled, pi r L. So here we have pi r L is the curved surface area of this right circular cone. Now one more thing, this is a right circular cone because this is rectangle. Can you see this? This is a right angle, this is a hypotenuse. So how you will find out the L? L square by Pythagoras theorem, L square is equal to h square plus r square. So L is equal to under root of h square plus r square. This is one of the formula we get. We want to find a total surface area. The total surface area is nothing but curved surface area plus base, area of base. What is the curved surface area? Pi rl. And what is the area of this circle? Pi r square. Now let us find out what is common. Pi r is common, so it is L plus r. So your total surface area is pi r into L plus r. Now we have to find a volume of this right circular cone. Now consider here two parameters are there. One is the r and one is the h. In right circular cylinder also we had two parameters, r and h. We have HR here and HR here. Okay. Now the relation between these two is the volume of cone is equal to 1/3 the volume of cylinder. This is the relation between their volumes. volume of this cone is 1/3 the volume of this cylinder. Can you guess that? Here on the top edge also same circle is there, but if you go on reducing, you will get the figure something like this. Okay, so the volume of the right circular cone is 1/3 the volume of the right circular cylinder of the same radius and same height. So let us find out the final formula for the volume of cone. So this volume is equal to 1/3 of the volume of right circular cylinder of the same radius and same height, that is pi r square h. So we have volume is equal to 1/3 into pi r square h. Again in this case we have only 4 formulas, and the all example based on the right circular cylinder are based on these formulas only. So let us see some solved examples and then we'll move to exercise. The first is the radius and slant height of a cone are 5 and 10 respectively. Find a curved surface area. Slant height is given, radius is given. You have to just find a curved surface area. Simple arithmetics is there, simple algebra. Then find a total surface area of a cone of a radius 6 and height 8 centimeters. Now in this case they have given the radius 6 and then they are given height 8 centimeters, and you have to find out the total surface area. Now for the total surface area you have to find a L first. So when R and H are given, you can easily find the value of L. Okay. Now once you get the value of L, just substitute R and L, that's all, and you will get the total surface area. Very simple in this case. So please solve this example, pause your video here and find out the answer. Also check your answer. Let us see one more example. Now this example is little bit tricky, not very difficult. The radius of cone is 7 centimeters. The radius is 7 centimeters. Find its volume. You have to find the volume if the height of the cone is double its radius. Height of the cone is double the radius, means it's 14 centimeters. That's all. Now you have to find out the volume. Volume R you know, H you know. You can easily find out the volume of the cone. Very easy. Only thing, the tricky, not even tricky, this is very simple. If they say that the height is double the radius, you don't have to even think about it. What will be the value of this H? Very simple examples. Let us see one more example. The height and the volume of cone are 18 and height is given 18 centimeter and volume of a cone is given 924 centimeter cube. 924 centimeter cube. Find the radius of the cone. You have to find the radius of the cone. Volume is given, height is given, you have to just find the radius. Direct substitution of formula. Correct? So please pause your video and solve this example. Now before going to exercise, first of all we see what do you mean by the frustum of a cone. Frustum of a cone. Frustum is a Latin word, the meaning of which is cut off. What is the frustum of a cone? Suppose this is cone. Now suppose if I cut this cone from here, what will happen? We'll get the block, solid block or figure something like this, whereas radius is R, this is the slant height, and one part cap like structure will get, this part is actually cut, right? This part we are actually cutting off this part from the cone. So this remaining part is called as the frustum of a cone. Now let us see the formulas for frustum of a cone. This was for the cone, and now we'll write the formulas for frustum of a cone. Now in this case we have R here, here we have two radius, so we will take R1 and R2 here. So first of all we'll find the length of the frustum of a cone is equal to under root h square plus R1 minus R2 square. Now what is the curved surface area? The formula for curved surface area is pi into R1 plus R2 into L. That is the slant height, or you can write LF here to avoid a confusion, because we have taken L here, so we will take LF here. So this is the slant height of the frustum. And now what is the total surface area? The formula for total surface area we can derive from here. We will first open these brackets by substituting R1 plus R2. Let us write down the final formula for the total surface area. It is pi R1 plus R2L plus pi R1 square plus pi R2 square. And at last the formula for the volume of the frustum is 1 upon 3 pi into h into R1 square plus R2 square plus R1 R2. So these are the four formulas on which the problems of the frustum are based. Now let us solve a few examples on this frustum and then we'll move to exercise. If the radii of the circular ends of a conical bucket, now the conical bucket is there, this is the bucket, okay, now they are given the radii. If the radii of the circular end of a conical bucket, which is 30 centimeter high, height is given 30 centimeters, are 14 and 7. This radii is 14 and this radii is 7. Find the total surface area and capacity of the bucket. Now when we want to find out the total surface area, what we will need? We will need slant height also of the frustum. Okay, so first you have to find out the slant height, because h, R1 and R2 you already know. R1, R2 you already know for the total surface area. For the volume h you know. First of all you have to find out the slant height, and slant height formula you know, h square plus R1 minus R2 bracket square whole under root. So very simple. First find out the LF, that is the slant height of the frustum, and based on that you can find out the total surface area and volume of this conical bucket. So please pause your video here and solve this example right now. Now in this case, slant height of the frustum you got 949 under root centimeters. The total surface area you will get 770. The total surface area you might have got 770 plus 66 into 949. Now the 949, taking square root of 949 is not very easy. Without logbook you will not able to find. Okay, so just keep it like this. Here just don't forget to write the unit, that is centimeter square, and the volume of this bucket is 10,780 centimeter cube. Please check your answers. Again I am telling you, don't try to solve this, just keep it as it is. If the taking square root is easy, if this is a perfect square, only then do it. Now here some students, I have seen such papers some student may think that 9 square of 3, 49 square of 7, so 3 into 7. No, it is not like that. This is the one figure. You may feel that I am talking something funny, but I have seen such paper. They have taken the square root of this like this, 3 into 7. No, it is not like that. Okay? If it is not perfect square, if you cannot find out the perfect square root of this figure or any such figure, keep it like that only. Just write the unit perfectly, that's all. Okay? Let us go to next example. The slant height of a frustum of the cone is 6.3. Now let us see the frustum is 6.3. The slant height is given 6.3 and the perimeters of its circular bases, now they are given the perimeters of these bases are 18 and 6. So P1 is 18 and P2 is 6. They are not given the radius directly. Okay? You have to find out the radius. What will be the P1? Perimeter is 2 pi r, or I'll say 2 pi r1, and here it is 2 pi r2. So what will be r1 here? It is 9 upon pi. So it is 9 by pi, and this is equal to r2 is 3 upon pi. After that, find the curved surface area of the frustum. Now based on this information, you have to find the curved surface area of the frustum. Very simple, r1, r2 given, slant height is given, you can find out the curved surface area. Please pause your video here and just find a curved surface area. Don't worry about this 9 upon pi and 3 upon pi, because r1 plus r2, the pi, 1 upon pi will be common, which will get cancelled with this. Okay? Just solve this example quickly. The answer is 75.6 centimeter square. This is the curved surface area of this frustum. Let us see one more example. The radii of circular ends of a frustum of a cone are 14 centimeter and 8 centimeter. You are given R1 14, R2 8 centimeters. If the height of the frustum is 8 centimeter, H is given. Find three things you have to find out. Curved surface area. Now in this case you have to find a LF also. Slant height of the frustum you have to find out. So based on this formula, you can easily find out the slant height of the frustum. Then you have to find out the total surface area of the frustum by using this formula. R1, R2, L are known. You have to find out L from this. And then you have to find out the volume of the frustum. That means they are asked everything. Okay? So you have to make use of all these formulas and find out the answer. Okay? Very simple example, direct substitution of formulas. So please pause your video here and you have to find out the curved surface area, you have to find out the volume, and you have to find out the total surface area. Okay? First find out the slant height and then you can substitute in these formulas and find out the answer. Please pause your video here and solve this example right now. Now in this case, the slant height is 10, curved surface area is 690.8, total surface area is 1507.2, and volume is 3114.88. If you have got this answer, these answers are wrong. Why? Simple thing, I have not written any of the unit. So you have to write the units. So slant height is 10 centimeters, surface area is centimeter square, volume is centimeter cube, and total surface area is centimeter square. Now the answers are correct. I am reminding you again and again, if in the example the units are given in centimeters or meters, and in the answer if you don't write that, I will give, if I am an examiner, I am a paper checker, I will give you 0 marks for that. Simple thing. But in board exam, they may cut you a half mark or 1 mark, something like that. Okay? So don't forget to write the proper units. Otherwise, you will do the example correctly, you will do all the calculation rights, but unnecessary some marks will be cut. So from this, now we will move to exercise 6.6, which is based on the cone and a frustum.